Sorry, this is a little bit of a test. Once I know this works, I will be very happy. Bum, 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 bum. Tweet. Are we live? Are we live? I don't know, just press go live. But are we? Are we live? I don't know. I have no idea. My computer's overheating, so yes. Perfect. All right. Confirmed. We're live. Hey, everybody. Let me just go quick tweet. Crap. That was the link we needed. We're live. Should your name for stuff about routers. Here's stuff about routers. Hey. All right. So I am Josh, and I will be talking about routers today. I hope the sound is good. There should be like a chat thingy on the streaming page. I don't have earplugs anymore, so I can't check the sound. But yeah, today I'll be talking about routers. Watching now. Oh crap! People are actually tuning in. Shit. Yeah. So I've got this project called Wayfarer, which is sorry, people are tweeting at me, which is a little router that kind of looks like an event emitter. You got your require Wayfarer there. I'm not sharing my screen. I should be sharing my screen. People let me know if anything's going wrong. I have like no way to check this. I'm working on a tiny little laptop. It's been ages since I last did this, but okay, router. So it's a little router, require Wayfarer. You set a default path. You've got a bunch of events, and then you get to match a route, and that executes that path. Internally, it uses a tree structure, which makes it like very fast. Like most other routers are based on an array, and then like every path is matched from top to bottom, and it's not very fast. It'll never be a bottleneck, probably, but it just feels wrong. So this guy Jonathan Ong came up with doing it as a tree. It's called Routington. It's pretty good. Wayfarer is based on this as of now. But I ran into a little issue with Routington like a while back. The second you want to nest multiple routers, Routington doesn't really work for you anymore. So I'm trying to do subrouting with Wayfarer, which is pretty cool. You get to define a router, another router, and then you mount one router onto the path of another router, which means like this will match into the first router, into the second router, and then match the path. And then if a path doesn't match, it should like default back to the first router's default path. That makes sense. I hope it does. Anyway, being able to split up your routers has like heaps of benefits because you get to split it out over multiple files, combine them. You get to like instrument them and then just return the underlying router instance and then mount it onto the existing like router definition. As long as the data structures match, it should like all work fine. So yeah, I'm trying to do that, and Wayfarer as of now does that, but the implementation's got a few corner cases. and is very ugly. Like, it took me at least several weeks of night work to like get this done. We're like looping all over the place in this thing. We've got double two tries to like have the routes defined on the route, and then the sub routers, and all the sub routers are like doing a bunch of stuff. The reason why I did it this way, which is obviously not too great, is because I made the mistake of, instead of mounting the internal data structures onto each other into like a larger trie, I actually was mounting the actual full routers onto each other, which makes for a very clunky implementation. So what I'm doing now, and what I will be doing today, is rewrite the damn thing. I started last night with a rewrite with my own little trie implementation. Let's open this up on GitHub. Bom, 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 bom. Bom, 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 bom. A little trie implementation. Sip of water. Because what Routington does is good, but we can do it better, I reckon. Actually, we can. I'm pretty much almost done here. Trie. Should I sketch this out? Does everyone know how trie works? I hope you do. Well, it's actually, you can think of it this way. If you've got your path /foo/bar/baz, whatever, then you would create an object which has foo, and then everything that comes after foo is like another object. So when you match like a full route, you just match a bunch of objects. And since it's key value lookup, it's very fast. You traverse the whole thing pretty much in constant time. Whereas if it was an array, you would traverse it like n, which is slightly more shit. Again, it will never be a bottleneck. So pretty much what we do is we create a new node for every section of the path and then mount it onto the previous one. And that's how we like nest a bunch of objects. It takes a bunch of memory, but memory is generally not the issue in the process. It's speed, because our computers are cool and new. So that's what we do. So when we create a new trie, we create a new empty trie, which has a property of this.trie, which contains an object, which contains nodes. Then we have a bunch of functions. The first one is create, which is like, hey, take this route and give back a node at position. So you say like foo bar baz, and then you get the node at baz, which is an object which contains nodes. So then you can like define any type of property on there, and then it will just be registered inside a router. We've got the match property, which is a search function. So you search for a certain route, and it either returns undefined if you can't find it, or it returns that node with all the properties attached on it and all the subnodes, if need be. And the last one is mount. Sorry, there's an airplane flying over. And mount is the method meant to mount another trie tree at position inside of the current tree. And if that position does not exist, we created. Yeah, that's about it. So this one is a bit of a superset of the previous two, which is fine. Okay, so I've explained what this thing is, how it was implemented, how it is implemented, well, how I am implementing it. Maybe more interesting is the use cases for this, because why would we want to have like a router? What are the interesting things we can do with routers? So I've got a few ideas for this. I'll just explain it in words. On the one hand, routers are very useful for client-side applications. Stuff like React router is React specific, but I should look it up. But this thing has a very interesting pattern that allows you to combine views as if they were functions and give a subview into an existing view that can be mounted inside of that view. Um, so imagine you have your generic site frame, like, hey, on the left-hand side there's a widget, on top there's like a bar, on the center there's a bunch of content, and you could like inject whatever needs to go in there externally, and the frame would just mount it and item for like the subnodes, which makes a compositional view, which creates like wonderful glue. Except this thing is like very React specific. Sorry, I just went for a run. I'm still a little bit, but yeah. So you like mount all these things here, and if they like match, if slash a user slash user ID matches, then this whole thing will be resolved. I kind of want to do the same, but not in JSX, not in React, just as a general solution using the fastest way we know of making routers, because I think that would be neat. It would work very well with Mercury, for example. So that's the one side. That is client-side routers. Then on the other side, for people doing servers, you probably heard about this thing called Swagger, which is a YAML-based implement specification for APIs. Now, I'm not a configuration type of guy. I don't like configuring things. I like making things, programming things. And you know, if I like need to use a little package and give it some options, like a bunch of functions, I'm happy with that. The Swagger templates take away from all of that, and I don't like that. So one of my coworkers came up with this approach of making a thing which could compile down to Swagger, because Swagger's got like a bunch of tooling around it. You like pass a Swagger configuration file into like this documentation stuff, and it like generates all these sites for you, like all this stuff around it, which is wonderful from a usability perspective, but we don't want to be using Swagger. So what he came up with was, why don't build a router that does the same thing as Swagger, because having a little bit of standard is useful, and then just spews out the configuration based on the stuff you passed in. So using Wayfarer, we could create an API gateway, which, well, it kind of needs, I like streams, so I'm going to make sure that it is able to do streaming stuff, which means just return values eventually. So yeah, you could specify, hey, here's a little description, which doesn't really do anything. You could specify permission stuff, and then like have your own permission handlers. Do your validation stuff, probably with like, is my JSON valid or something like that. Like JSON schema is very good. Like your response, how your responses are formed, you could specify, and then eventually a handler function. It's a little bit boilerplatey, but if you want to document the API you're building, you do need something like this. You do need something structured. If you don't use something as structured as this, you will end up having to write all documentation manually, which means it'll A, be tedious to do, and B, will go out of sync. So I think this definitely beats like having a configuration-based thing. So yeah, that's like the other use case I want to go for. And then like for simpler patterns, we could do api.on/index.html. You just give it a function, and it should just work. It should just return the value of that function. Or /get, it should just, and you mount a function on there, it should just return that. But if it has an object with like the full thing, it should be able like, hey, I'm like this very fancy API, which can compile down to Swagger if you like. And it's like, oh, rad, you know? Like it takes care of all your API needs, from like very early to like super complicated, but should be fully configurable and like do whatever type of validation you like and whatever. So that's the other side I want to be tackling. But in order to do that, we must build our tree. I believe the correct wording is tree, but you spell it as try, which is super confusing. Hope everything's still going good. Well, nobody said something in chat. I seem to be uploading like heaps of data, so I'm probably streaming still, right? Yeah. So to do away with this implementation, do away with Routington, like pretty much most of the dependencies, I'll be extending this thing. Right. Okay. So I'm working on branch simplify, which I started like a few months ago, but never came around to finishing. Yeah, we don't have too many files. We have index.js, our test.js, which contains, hey, our tests and our new file, tree.js. So this is tree. Like I said, this is a tree implementation. We've got our create function, our match function, and our mount function. Those are 3 functions. And a little reusable thing underneath, which I'll come back to later. Index.js is pretty easy. Well, I say easy, but it's all relative. It's just not a lot of code. So I'll walk you through it. We create a new Wayfarer instance, which has a default path. Either it's default or, well, it will throw otherwise if you don't match anything. That has a .on function to register stuff and a .emit function to call stuff, match stuff, which then either talking fast, drinking water, excuse me. Yeah, which either matches something, matches the route, or matches default path, throws otherwise. As you can see, I'm doing, I've got like a bunch of debug statements everywhere. I was working on this last night, fell asleep, but halfway through debugging. So yeah. Okay, so that's running tests. Bum, 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 bum. Debug statements everywhere. Okay, how do I do that? So if we go to test, these are pretty well constructed. First test is like, hey, match a single path. Well, that seems to be working. Match a nested path, foobar. Well, that seems to be working too. Then there's like, hey, please have a default path. Also works. Bunch of type error testing. Check if it matches partial paths. Yeah, it like returns parameters. Like there. Wait, is my face? Ah, yeah, you can still see my face. Cool. Then there's like other stuff about stuff, but the interesting part here is the nesting part, which is combining routers. Maybe I should say instead of nesting, should mount sub routers. I think that's fair to say. Should mount sub routers. Cool. So for this test, we create a Wayfarer instance R3, R4. On R4, we actually, for correctness, let's do it this way. So R4 has a path called getlet. Once getlet is called, we're like, hey, pass the test. Then we create 3, we mount 4 on top of 3, and then call /mom/getlet, which should call this line. Now, npm t, npm test. So on npm test, for those who don't know it, I'm running standard and a test. We've also got test cov, but that's not relevant for now. Almost no dependencies too. If you look here, we're only using extend. We removed Routington. So this little module should be like very, very self-contained, which is nice. Oh crap, did I just close all things? Crap. Right. Let's close this window, and we're back here. Just a minute, we need to go to test because that's where we were. Here. So R4, R3, these are failing. You can see that here. So it says, hey, the path did not match. Why not match? Well, it's trying to match on this. So /mom/kitlet. Sorry, it is trying to, yeah, here. Mom kitlet, it should be, but it's mom kitlet, which is bad. Oh, I'm like inhaling too much air, but that's all right. I'll just drink more water. So we're double mounting mom. The path mom is being mounted twice. Let's phrase it that way. Let's try and stay nice towards people with moms. Right. Okay. So obviously our try implementation is where it should be at, because if we look at it, we are correctly creating a try with a node called kitlet. We're creating, we're creating an empty try here, which doesn't really do anything. So when the path mum is created, it's created by mount. So mount is the function that is screwing up, which we need to debug and fix. Okay, so let's go to mount. Mount takes a tree, takes a route initially, which is the mount path, and then tree, which is the tree that should be mounted on that path. So we get, check for that. We split the route up into little pieces, remove the leading slash so we don't get an empty string initially. Create a bunch of bogus stuff. Oh, I just added this.